Alright, and welcome to solving exponential equations. Now for our very first example, we have 20 is equal to 1/2 4 raised to the power of y. Notice that my variable is in the exponent. That's how you know it's an exponential equation. Plus 12. Okay, so I wrote PEMDAS from the bottom up over here to the right. And so let's kind of see what things do we have going on. Here, since there's a single term inside the parentheses, we don't actually count that as a parentheses. We see that we have some multiplication. I see that I have some addition. And of course, we have that y up in the exponent. Okay, so going from the bottom to the top, the first thing I want to get rid of is my addition. Well, the opposite of addition is, of course, subtraction. So we can subtract 12 from both sides. And remember, there's my 0 pair. Well, 20 minus 12 would give us 8. Okay, so now we have 8 is equal to 1 over 2, 4 to the power of y. Alright, at this point, we know that to get rid of our multiplication, typically we would divide, but here we have a fraction. So we multiply by the reciprocal. Well, the reciprocal of 1 over 2 is 2 over 1. But notice 2 over 1 is really just like saying multiplying by 2. Well, 2 times 8 is, of course, 16. And now we get to the interesting part. We have 16 is equal to 4 to the power of y. Now, this y is up in the exponent. So we need something that is the opposite function of an exponent itself. And in this case, this is where we write what's called a log or a logarithm. In order to get the exponent out of the exponent, we take the log of both sides. Now, when you take the log of anything, what you can do is the property of the logarithm, since it's the opposite of an exponent, you get to bring that exponent down in front. So like, what would this look like now? This now is the log of 16 is equal to, we bring our exponent down in front, so we have y log 4. Now from here, this is actually fairly simple. What you want to do when two things are side by side, they're being multiplied. So now it's like we have some more multiplication. We get rid of that multiplication by dividing both sides by the log of 4. And I divide this side by the log of 4 as well. And so I'm going to bring this y over here to the left, and what we really have is y is equal to the log base 4 of 16. This is how you rewrite the log of 16 divided by the log of 4. You write it as just a single log where we write the 4 in this little base space of 16. Now from here, you need to go to a calculator to plug that in. So let's pause the video and I'll show you where to find an appropriate calculator. Okay, so here in our window, we can type in logarithm, and I'll let you kind of pause the video there if you need to, but logarithm, and something will pop up like Logarithm Calculator. And notice we probably don't want to use this one. So let's just go down here to Logarithm Calculator. And so basically in our problem, we have a log base 4 of 16. So we'll put a log base 4 of 16, and let's see if this one works. Calculate, and it turns out the answer is 2. Alright, so this logarithm calculator works just fine. What if you had typed on the second one? Okay, so here what you do, you find the little log button, and you say, okay, well we have a log base 4 of 16, and you click go, and it's telling us, you know what, the log base 4 of 16 is 2 again. Okay, so that's pretty easy. Here we can say that y is equal to 2. Alright, let's go on to our second example. Okay, let's take a look at example 2. Here we have 600 is equal to 5, parentheses 5, raised to the power of p. So notice since our variable is in the exponent, this is what makes it an exponential equation, minus 25. Now from here, let's go and label all the things that we know. We know that we have we have multiplication. Let's star that right there. We know that we have that p up in the exponent, and of course we have some subtraction. So going from the bottom up, let's get rid of our subtraction first. The opposite of subtraction is, of course, addition. So let's go ahead and add 25 to both sides. Well, now we have 625 is equal to 5 times 5 to the power of p. Well, how do you get rid of your multiplication? The opposite of multiplication is, of course, division, so we can divide both sides by 5. And 625 divided by 5 is actually 125. Okay, is equal to 5 to the power of p. Now remember, this is where it gets a little bit trickier. How in the world do I get the exponent out of, or the variable out of the exponent? Well, the opposite operation of an exponent is a logarithm. So we're going to take the logarithm of both sides. And this p gets to come down in front. So we'd write our next line like this. The log of 125 is equal to p log of 5. And here, notice that these two things are side by side, so they're being multiplied. And what is the opposite of multiplication? Well, we're going to divide both sides by the log of 5. Now remember, you can actually rewrite this. So those cancel out, and this is what we have. We have p is equal to the log base, whatever logarithm is on the bottom, that becomes the base of the logarithm of 125. So let's go back to our calculator. So we have a log base 5 of 125. So here, let's go ahead and delete that. And we can go ahead and write a 5. Oh, I'm sorry. Here, we'll just delete the whole thing. We can go click log base 5 of 125. We'll click go. And it turns out the log base 5 of 125 is 3. And so we can say this, p is equal to 3. Alright, I hope this helps, and I'll catch you in our next video.